So hello guys, today we are going to discuss this lead code problem, that is copy list with random pointer. So the problem is something like this, that we are given a linked list, but it's a sort of a modified, it's sort of an enhanced linked list which has a next and a random pointer in it. So a linked list is a data structure which stores address of the next node in the present node. So this is the linked list, that it has a value, it has a next pointer and a random pointer. So the question says is we have to copy this whole linked list and return the same. And the problem only, like the question only has provided head pointer. That is, head pointer is if it is 7, it's only till here 7, and so on. So so if you try to understand, the basic problem here is that how we are going to copy the random pointer. So if linked list doesn't have this random pointer associated with it, so we can just directly go on to the linked list, traverse to the next node in a recursive uh, function manner, and then while traverse, like returning from the recursive function stack, uh, the node can actually point to the newly created node. Uh, so we'll need an enhanced version of it. I'll just explain here. So what I have done is I have taken a hash map, and on every node when I traverse, I insert, I first of all I copy this node. That is, when I go to this node 7, I copy it in to a new node, that is 7. Next would be null, random would be null as well, and I insert that entry into the hash map if the entry doesn't exist. So if this is the condition here, that in an ordered map I find that whether this entry exists or not, and then I insert the entry into the hash map. So if entry exists, I'll be returning the newly created entry, otherwise I'm inserting it into the hash map. So let's take an example to understand it. So for example, we have this linked list here. Uh, there is a node 7 which points to node 11. Node 11 is here, and its address is 70. So I have taken 70, this one 13O and 11O for the old linked list, and for the new linked list I have taken 7N, 13N and 11N. So initial linked list provided to us is that it 7 points to 13, 13 points to 11, and 11 points to null. So here it is null. And for the random pointers, for the 7 random points to 11, for 13 it points to 7. So this is not there, like it's missing. And then the node 11 random points to 13. So here. So how we go ahead in this one? So let's start with 7o. So 7o is our head pointer or the base pointer which will be provided. So whenever we are in function 7o, this one fun 7o. So in that case, what we'll do is we'll search the map, unordered map search. So in this case, we'll not find the entry in the unordered map, and we'll allocate a new node. So we have a new function, a new operator which actually allocates it. So if we see here new, so what we do is we allocate a new node which will be copy of this one, that is which will have 7 as a value, next and random will be null. So I am allocating it using this, that is new node head and value, and next will be null, random will be null, because we are calling this constructor. And then after allocating it, we will be calling the next, that is next of the current node, into the recursive function. So I'm just calling 130o because this one 13o, because next is 13o. So it goes to 13o, then again it searches that whether I can find 13o into the linked list or into the unordered map or not. So it doesn't find, and then again it creates search fails, unordered map search fails, and then it again allocates 13n, and this entry is created on the unordered map, and then it goes to the next of 13. So next of 13 is 11. So it goes to 11O. Now on 11O, it again searches for the same, that is whether I can find 11O inside the unordered map, which it fails. So it again allocates and puts it on the unordered map. So we have these three entries allocated. So just beg me pardon. So this is 11O and 11N. Okay. Now what happens? It goes to the fun of the next. So fun of next here is null. So this is null because 11 next is null. So now it comes to fun of this one here, that is fun of head, which is null, and it returns null. So now uh, next pointer of 11O, that is sorry 11N, will be null. Now it goes to like to fill the random pointer for um, this one 11N. So this temp basically is 11N here, right? Because we have allocated a new node for 11N, which is 11O, which is 11N. Now it goes to the function, like we jump to a function for 13O. Why 13O? Because for the current node, the head, this is 11 for head, this one, we are here. The random for this one is 13, so it will go to here 13O. So it jumps to 13O function, that is on node 13. Now it comes to node 13, and on node 13 it checks that whether I have a value in an ordered map for 13 or not, that is whether this address is present or not. So we already have filled this address here in this step, and we return uh, this one, that is the value for it. So in this, if we see, if we find a key that is head, in that case we'll return a value. So now we get value, that is 13n, and we return 13n from this one 13 function, that is 13 old returns a 13 new. So this temp returns here. So now this random is filled with what? This is filled with 13n. So for 11 new, so if we see here, for 11 new, random will be equal to 13 new, next will be equal to null, and we return 11n here. So now this function reaches here. So it calls uh, fun of 11 old. So on 11 old, that is um, no, it is on 13. So it calls 13 next. So 13 next is this. So this way we actually recursively call the function, and if we have the unordered map already filled, we pass the value, that is we return the value, and this whole new linked list is actually filled with the values. That is for the key we return a value, and this actually gets filled. So this is how it works. For the time, for the complexity calculation, the time complexity would be 2on, because we are allocating n stacks here. If let's suppose we have 5 entries, so we'll be calling copy random 5 times, so 5 stacks here and 5 stacks here. So it will be total 10 stacks. So this will be 2on, so we can say it as a on. And for the space complexity, we are taking this unordered map, which will be of on size. Also, this stack actually occupies space, we can consider that as well. So space complexity is also on. This will be on, and this will be on plus on, so maybe 3on, which is equivalent to 1. So that's how it is. So the solution is accepted. Um, yeah, thank you, have a good day.